Hello guys, it's Ansai from Mixed Training. Welcome to this series building fluid solvers. So this course will be just concerned about building fluid solvers from scratch, the mathematics, the physics and the mechanics behind this process, okay? So in our lives, the field concerned about simulating fluids on computers is called CFD, and we use some techniques from it to simulate fluids on on our computers for the graphic and visual effects scenes. Okay, so this CFD is just studied in computer science and engineering for building bridges and a lot of stuff. So yeah, we will just use some techniques, or we will use the this CFD work here with some exceptions to just make our simulation easy and fast for the graphic and visual effects scenes. Okay, so this process is not easy at all, and it needs a big knowledge of math, physics, mechanics, and more. Okay, and it's very hard to learn all of this stuff from the internet individually, because yeah, you don't want to learn all of the masses or all of the physics or all of the mechanics, which is called fluid mechanics. Okay, just to build a fluid solver. So what I will do in this series is that I will do my best to explain things simply. We'll start with the math, okay, and we will end the series by building a simple fluid solver. Okay, so we will just start in this course with the math. Okay, we will start with the basic start point that we will all understand from, okay, which is differential calculus, and this is the most basic level of calculus we will learn, which is what is a function. We'll learn what is a function and how can we take derivatives and differentiate functions, which is really basic for some guys. And yeah, this may be something like a puzzle or some words that a lot of people don't understand. But yeah, don't worry, we'll just explain all of these things. So after the differential calculus, we'll talk about the inverse. The inverse operation is called integration, and the branch is called integral calculus. So we will just simplify these definitions, and we will enter the world of multivariable calculus, which is the core of our work. We will use the multivariable calculus operators, functions, yeah, in everything in fluids. So we will talk about the multivariable functions, which we will express everything in fluids as. Okay, so we'll explain we'll express velocity, position, yeah, a lot of stuff will be just expressed as multivariable functions. Okay, and then we will talk about the different differential operators or the derivative operators of the multivariable calculus, like gradient, curl, and divergent as the divergence. Okay, so we will use all of these operators in fluids, and you will see this in this series. Okay, then we will integrate the multivariable functions. Okay, this will be our first course, which is concerned only about math. Okay, this course is very important because it's the base that we will build our following concepts on. Okay, so if you know maths, or if you know just the titles I have talked about, you can just skip this course and go on the next one in the series. But I strongly recommend watching this, because later we will explain things in fluids, or in the equations of fluids, in a similar ways we will do here. Okay, so such an example, or for example here, the definition of derivatives. We will use it a lot when we talk about differencing. Okay, so this will be our first course. Without further ado, let's go.